Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here, our second video on circles and straight lines. Let's start with something I want you to know. Previously on Hegarty Maths, when we solve quadratic equations in the quadratic section, any general quadratic of the form ax squared plus bx plus c equals 0, we realized that we could solve it by the quadratic formula given here. But we also realized there were three cases about a solution depending on what we called the discriminant, which was b squared subtract 4ac, the thing underneath the square root, the expression underneath the square root, so the discriminant. Now, can you remember if b squared subtract 4ac is bigger than 0, equals 0 and less than 0, what the conditions are on solutions? Pause the video and double check you can remember that. Well, you should have remembered that if b squared subtract 4ac is bigger than 0, you get two real x's. That are two x's on the number line. If b squared subtract 4ac happens to equal 0, you get one repeated solution. If b squared subtract 4ac is less than 0, you get no real solutions. So I need you familiar with that idea, so go back to your building blocks if that's unfamiliar to you. The next thing we need to talk about are circles and straight lines. Now, the general equation of a straight line is y equals mx plus c. The general equation of a circle is x subtract a all squared plus y subtract b all squared is equal to r squared. And in the previous video, we worked out where they intersected, which was here and here, by solving two simultaneous equations and the technique of substitution. So as by way of a warm-up for that, I'd like you to practice the following question. So find the points of intersection of the following circle and straight line. Pause the video and double check you can do that. Well, that was in the last skill. You must be able to do that for this particular skill. It was a technique of substituting y from the first equation into the second equation. You get, which we're going to talk about later, a quadratic when you do that at the end, which you go on and solve to find your x's and you substitute back in to find your y's. And that's how we found the points of intersection. Now there's something I just want to finish off by showing you there are other cases. You don't always have 2 points of intersection, and I wanted to start with that. So, a circle and a straight line. The case we've already dealt with is where you have a circle and a straight line and there are 2 points of intersection, here and here. And we found them already. But there's another case. Can you think what other scenario could happen if you have a straight line and a circle? Well, they could actually just touch here. Just touch. So have one solution. And when a straight line touches a curve, it has a name and it's called a tangent. Okay, and that's an important word we'll come back to. So they touch and there's one particular solution. Can you think of the other scenario? It's pretty straightforward. They don't touch at all. They never intersect. Okay? And we can actually find that out without having to necessarily work out the answers. Because when you do your substitution trying to solve them and you get a quadratic, okay, like here, you do the substitution and you come down to that line and get a quadratic, there is a condition that's true. And here is the condition. If b squared subtract 4ac for this quadratic you get down to is bigger than 0, you get two real distinct solutions, so you get 2 points of intersection. Now, if b squared subtract 4ac is equal to 0, you're going to get one repeated solution, which means 1 point. And it means the line is a tangent. Okay, the line must be a tangent for it to meet at one place. And if you get b squared subtract 4ac is less than 0, that means they don't cross. There's no real solutions to the quadratic, so the straight line and the circle don't cross. So what you could do is, when given a problem like this, you could do the substitution, get down to your quadratic line, work out the discriminant. With a is 2 here, b is 6, and c is negative 56. If you did that, and you got b squared subtract 4ac is bigger than 0, you know that you have two intersection points. You could go on and find them. If you found that b squared subtract 4ac was equal to 0, you know that that point there only touches the line, so the line must be a tangent to it. And if you get b squared subtract 4ac, they don't cross at all. So we're going to use the discriminant to decide how a circle and a straight line meet or don't meet or just touch. So here's our first example. The question is, show that y is equal to 7x add 10 is a tangent to x squared plus y squared equals 2. Pause the video and have a go if you think you can. Right, the first thing we're going to do is write down the straight line. Y is equal to 7x add 10. We're going to call that equation 1. We're then going to write down the equation of the circle, which is x squared plus y squared is equal to 2. We're going to substitute 1 into 2. So sub 1 in 2. Okay, and what we're going to get? Well, we're going to get x squared add, instead of y, we're going to have 7x add 10 all squared is equal to 2. Keep that x squared there. Let's try and expand this bracket in our head. 7x all squared is 49x squared. And the middle term is going to be double. 7x times 10 is 70x. So you double that is 140x. And add 100 is equal to 2. Then what I'm going to do is I'm going to collect like terms. I'm going to collect the x squared there and collect the 49x squared there. And I'm also going to subtract 2 off both sides. So I've got a quadratic equaling 0. And I'll get myself the following. I'll get 50x squared add 140x add 98 is equal to 0. Now at this point, before I proceed, I could simplify this, but I don't have to. I could state that A is 50, I could state that B here is 140, and I could state that C here is equal to 98. And I could work out B squared subtract 4AC, the discriminant of that quadratic, the quadratic that came from this substitution. So let's have a go at doing that. You'd be allowed to use a calculator, so you would say 140 squared, take away 4 multiplied by 50 multiplied by 98. Now when you do that in your calculator, you get the answer 0. And because you get the answer 0, you can say that this quadratic has one solution, so these two must only cross in one place. Therefore this line must be a tangent to this circle. So you must state the logic there to get yourself home and show that it's actually a tangent. So therefore you can use 3 dots here. The line and circle only meet at one point. Therefore the line is a tangent. And you're done. You've shown it. Right, let's try another one. Pause the video and have a go at this one yourself. It says show that the straight line and the circle given by the equations below never meet. Same old stuff. Call that equation 1, call that equation 2. Substitute equation 1 into equation 2, and what would we get? Well, we would get x subtract 1 all squared add, and we'd get 3x add 5 add 3 all squared is equal to 2. Now let's expand that. This here expands to x squared subtract 2x add 1. Now this here, let's just combine this before we expand. That is 3x add 8, isn't it, all squared? Okay, just doing a bit of tidying up in our heads. And expanding that out, you would get 9x squared plus 48x plus 64 is equal to 2. Okay, now let's collect some like terms. X squared add 9x squared is going to be 10x squared. Negative 2x add 48x is going to be it's going to be positive 46x. Here you've got a positive 1, you've got a positive 64, and if you don't mind, I'm going to also subtract 2 from both sides, okay, just to make the quadratic equal 0. So I'm going to have myself 10x squared add 46x. 1 add 64 is 65, but then take away 2 is add 63 equals 0. A in this case is 10, B in this case is 46, C in this case is 63, and we can work out B squared subtract 4AC. We can say it's 46 squared, take away 4 multiplied by 10 multiplied by 63, And if we tap that into our calculator, you type in 46 squared, take away 4 times 10 times 63, you get yourself negative 404. And therefore you can state just a little line here. You should go down the page if you can. Therefore, the line and the circle have no points of intersection, no points of intersection, therefore they never meet. And we're done. And that's it for this particular video. Thanks loads for watching.